Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject electrical and electronics engineering. We're going to see the principal working types and configurations of BJT transistors. Bipolar junction transistors is very important concept for any electronic and communication student. This is very basic video to understand the working of BJT transistors, right? So we will see what is bipolar junction transistors, what is the symbol of it. We will see the different types of these transistors in this video. To start with, you ought to first understand what is transistor. Transistor is an semiconductor device. It can be an electronic device which can be used as an amplifier, which can be used as an oscillator, or it can be used as a switch. And you have different types of transistors, and here we are seeing BJT, bipolar junction transistor. And why it is called as bipolar junction transistor? It's because the operation depends upon the interaction between both majority and minority carriers. So far in previous videos we have seen the working of PN junction diodes, where the working is mostly depends upon the majority carriers. Whereas here it is called as bipolar junction transistor. That's because the operation depends upon both majority and minority carriers. And we can use this transistors as an amplifier circuit or an oscillator circuit in any digital circuits, and it can be used in computers, satellites, and modern communication systems, right? And there are two different types of BJTs. One is NPN transistor and PNP transistor. So what is NPN transistor? If a P-type material is sandwiched between two N-type material, then that is called as NPN transistor. Similarly, if an N-type material is sandwiched between two P-type material, then that is called as PNP transistor. And if you take any NPN or PNP transistor, you can see you have three different terminals. One is emitter, base, and collector. Emitter, base, and collector. And by construction, the doping levels of these three terminals are different, right? That is, emitter is highly doped and base is lightly doped, whereas collector is moderately doped. So emitter is heavily doped, base is lightly doped, and collector is moderately doped, right? And whenever it is NPN or PNP, the current conduction will take place from emitter to collector, and that is why the construction of this particular transistor is like emitter is highly doped and base is very lightly doped and collector is moderately doped. And apart from these terminals, you have to understand you have two junctions. That is, we are going to combine, we are going to join two N-type material, right? And in the middle we will have P-type material, right? That is, a P-type material is sandwiched between two N-type material. So because of this, we can have two PN junctions formed, right? And this junction is emitter junction, and this junction is collector junction. We can also call this emitter base junction, and we can also call this as collector base junction. This is the important construction that you have to understand in BJT, right? And coming to the symbol of NPN and PNP transistor, everything is same. The only the arrow mark is the difference. That is, for NPN transistor, the arrow mark is pointed towards emitter, whereas for PNP transistor, the arrow mark is pointed towards base, right? You can see for NPN transistor, it is pointed towards emitter, whereas for PNP transistor, it is towards base. This is very important information that every EC student must know, right? And coming to biasing of transistor, right? I already said we have two important junctions in transistor. We have three terminals and two junctions, right? And whenever we want transistor to work properly, that is, we can use the transistor as an amplifier or oscillator or switch. In order to make the transistor to work as an amplifier or an oscillator, biasing is very, very important, right? That is, normally the normal biasing condition is whenever we want to bias, we want to make the transistor work as an amplifier, right? In order to turn on the transistor, what you have to do is we have to provide forward bias to emitter base junction. Emitter base junction should be forward biased and collector base junction should be reverse biased. You already know what is forward bias and reverse biased in PN junction diode, right? So forward biased in the sense you have to give positive terminal to the P side and negative terminal to the N side. In reverse biased, what do you have to do? You have to give positive terminal to the N side and negative terminal to the P side. So you can see here, this is NPN transistor, whereas the forward biased here, we are giving negative terminal to N side and positive terminal to P side, which is forward biased. Similarly here, this junction has to be reverse biased, so the P side is connected to negative terminal, whereas the N type is connected to positive terminal. Similarly here, it can be N type or an NPN or PNP. This is the condition. The emitter base junction has to be forward biased and collector base junction has to be reverse biased. So you can see here forward biasing, P side is connected to positive terminal and N type is connected to negative terminal. Similarly, this is reverse biased, so positive is connected to negative terminal and N side is connected to positive terminal. This is about transistor biasing. So, right? So biasing the transistor is very, very important. That's because only depending upon biasing we can have different applications of transistor. I have already explained about these terminals, and you know that these terminals, emitter are highly doped, and whereas base region is lightly doped and collector is moderately doped, and you have two junctions here, emitter base junction and collector base junction, right? And for the working of transistor, you have to understand three different regions. One is active region, another one is saturation region, another one is cutoff region. You know what is biasing of transistor right now, and active region is where the transistor can be working as an amplifier. We can make the transistor to work as an amplifier. So which means the emitter base junction has to be forward biased and collector base junction has to be reverse biased. This is the normal biasing condition of a transistor. If both the junctions are reverse biased, then the transistor will be turned off. It is called as cutoff region. It is working in the cutoff region, that it will be turned off. It will be working as a switch. It will be working as a switch. That too, it will be an open switch. It will be an open switch. Whereas in saturation region, transistor will be on always. That is, both forward bias, both emitter base junction and collector base junction are forward biased. Even here, it will act as a switch, and this switch will be a closed switch. Closed switch. And sir, I already said it can also be worked as an oscillator. That is, if an amplifier, to make the transistor to work as an amplifier, we have to make the transistor to work in an active region. So that we have to give forward bias in the emitter base junction and reverse bias in collector base junction. And the same amplifier can be can be converted to an oscillator circuit by providing a feedback. Right? If we're going to connect a feedback network along with the amplifier, it will create a sustained oscillation which can be used as an oscillator. Right? This is very important information regarding the region of operation of transistor. Right? And coming to working of transistor, the working is same for both N-type, NPN and PNP transistor. Already you have understood the working of PN junction. Similarly, this is same like the PN junction diode. Now, you know that in N-type, we have electrons as majority carriers and holes as minority carriers. And in P-type, you'll have holes as majority carriers and N's as and electrons as minority carriers. right? And you know what is forward biasing here? This is NPN. So I have given negative terminal to the N side and positive terminal to the P side, right? And similarly, this has to be reverse biased. So negative terminal is connected here and positive terminal is connected here. And what happens here? We are giving negative supply to the N side, and because of that, repulsion will take place, right? Which will make the electrons to flow towards this particular base, right? It crosses this particular junction, right? And all the electrons here, we know that the width of the base region is very small. It is very lightly doped and it is very small, and you have only fewer holes there, right? Because of a small region. So the number of electrons coming out from this emitter crossing this particular junction will reach the base, right? And small recombination will take place, right? Say for example 5%, that is if 100% of electrons are coming out here, right? Say then 5% of electrons will be recombined in holes, and remaining 95% of electrons will reach the collector, will constitute the collector current, right? The electrons flow from emitter to collector constitute the collector current, right? And this current, this flow of electrons, right, constitutes the collector current, and the relationship can be mentioned like this: IE is equal to IC plus IB. That is, the emitter current is the addition of collector current and the base current, right? So the working is same for PNP transistor. Only thing is the majority carriers will vary. If you take the working of NPN transistor, we are going to do the same thing. We are going to give forward bias here and reverse bias in this particular junction, and because of positive terminal, the holes here, which is present here, will be rippling towards the collector, right? And first it will cross this junction and reaches base, whereas the base you will have fewer electrons because the width of the base is very less, right? So fewer electrons will be present, and some of the holes will recombine with that, and remaining 95% of holes will reach the collector, constituting the collector current, IC, right? Once again, the emitter current can be written as IC plus IB. So the operation is same. Instead of electron flow, here the flow of holes creates the flow of holes from P to N creates the conduction, right? But overall working, both majority and minority carriers are involved here. You can see in base both are recombine and produces and the remaining of the electrons or holes reaches the collector. But the reason of conduction is because of flow of holes from the emitter, and similarly for NPN it is because of electrons from emitter to collector, right? So this is the working of NPN PNP transistor. Another important information in transistor is configuration. If you take any particular transistor, right, and there are three types of configurations. One is common base, common emitter, and common collector. This is the common base configuration, whereas in common base configuration, emitter will be acting as an input terminal and collector will be acting as an output terminal. And if you take common emitter configuration, base will be an input terminal and collector will be output terminal. Whereas in common collector configuration, base will be input configuration, input side, and output will be collector terminal, right? And this base, common base, can also be called as grounded base configuration, and this can be called as grounded emitter configuration, and this can be called as grounded collector configuration, right? So today what we have seen is, we have seen the introduction to BJT transistors, we have seen the symbol of BJT transistors, the working of BJT transistors, and configuration of BJT transistors. I believe this video will be useful for you. Thank you, my dear students.